Hello, I'm Daniel.
I'm Luke.
And I'm Zane, and we're all members of the Rocket League team for EECS373 at the University of Michigan. Our class is focused on embedded systems, so over the course of the semester we worked on an embedded systems project where we tried to recreate the game Rocket League in real life. This included RC cars simulating a game of soccer, and it incorporated components like RFID tags, PWM controlled servos, motor controller boards, FPGAs, and Arduinos, as well as computer vision on a Raspberry Pi.
So we start over here with the N64 controllers we take the inputs and put them on the FPGA. The FPGA also takes inputs that control the turret from the Raspberry Pi. These inputs are then parsed and sent using packets, using the XPs sent to the cars. The cars also send back at RFID tags that they run over through the XPs, and the FPGA then parses out which RFID tag was hit and then gives the power up back to the cars themselves.
So here are one of the two vehicles we have in our Rocket League game. As you can see here, we have the continuous servo, and then underneath the outer structure, we have two Arduinos as well as a Smart Fusion FPGA. One of the Arduinos is hooked to the XP that sends and receives data with the main Smart Fusion base that Daniel talked about. This information is split between the three devices here. The first Arduino is used to control the motor involved with the car. The second Arduino is used with the RFID information. On the base of the car here, you can see an RFID tag reader that reads the tags whenever the vehicle drives over them. Finally, the Smart Fusion is used to control the 360-degree continuous servo located here, using the information sent from either the N64 controllers or the Raspberry Pi, and then received here via XP.
The RFID tags placed on the field give different types of boosts to the car. This one, for example, gives a speed boost to the blue car, as you can see it being faster than the yellow car. With the auto camera tracking feature enabled, OpenCV tracks the location of the ball and cameras and sends signals to the FPGA to reorient the cameras to face the ball at all times.
So overall, this was a great opportunity to experience a full-fledged embedded systems design project in a great team setting. With any sort of big project like this, we were bound to run into some issues, and so one issue I ran into was some material interference with the RFID tag and reader. This is caused by the metal plating underneath the car. And so to overcome this, we took a piece of cardboard to block the metal, because cardboard wouldn't interfere with the electromagnetic waves as much. And this was a great solution to the problem.
Yeah, and one of the problems I ran into was while operating the OpenCV code, we found that as we changed from room to room, the lighting conditions changed a lot, and it made our code run inconsistently. So in order to fix that, we made a couple scripts that made it really easy to calibrate the camera for each room that we went into.
And we'd like to thank both of our professors, Mark Rehab and Matt Smith, as well as Stryker, for helping us fund this project.